Number 1 says, Sam said that a typical flight delay for the 60 big air flights was approximately 1 hour. Do you agree? Why or why not? Look, the dot plot of December delay times, and then the dot plot is in minutes. So we say we do not agree. So if we look at this, we can definitely say that it is skewed to the right. Therefore, is the median or the mean a better indication of the typical value? The median would be. So if we look at that, I would say the median's probably between 20 and 30 somewhere, not 60. Okay? So I would say it's somewhere in between there. Now, number 2 says, Sam said that 50% of the 22 juniors at River City High School who participated in the walkathon walked at least 10 miles. Do you agree? Why or why not? Well, according to this, you can't tell anything. Let me... Let's do this. Move that up there. Okay. Now we can see what's going on. So over here is the 10, which you can definitely tell that they obviously are not walking anywhere close to 10 miles. So we do not agree again. And what it is, the majority, what does it ask for? Someone said that 50%. Well, we know that this is 50%, right? Okay. But the majority of them are walking somewhere around between 8 and 9-ish. So that's the reason why we would say that no, they do not walk 10. Page 13. Number 3 says, Sam said that the young people from the ages 0 to 10 years old make up nearly 1/3 of the Kenyan's population. Do you agree? Well, first of all, what is 1/3 as a percentage? So 33 and 1/3%. So we need to look at the ages of 0 to 10, which there's 17, and here is probably 15. We add those up, we have 32%. So that is nearly 1/3. So yes, we agree this time. And that is why. Because the ages between 0 and 10, this is the percentage that makes up those ages. So we would just add those ages together and get 33. Page 14. I don't know if we're going to do this one or not, but it's a little long. Each person in a random sample of 10 ninth graders was asked 2 questions. How many hours did you spend watching TV last night? And what is the total value of coins that you have today? Here are the data for these 10 students. So we have the hours of TV and the value of the coins. Now, it says construct a dot plot of the data on the hours of TV. Would you describe that the data distribution as approximately symmetric or skewed? Now, Do we want to do all of that? Well, you were supposed to. Let's see here. We'll go ahead and do it right quick. So if we did this, we would have 0, 1, 2, 3, 4. Any more than 4, I don't see any. Okay, so we have a 2, 1, 0, 3, 4, 1. Oh, that's not a 1. 1, 2, 2, 4, 3. So yeah, we would call that normally distributed or symmetrical. Okay. Now, if you wanted to describe a typical number of the hours of TV watched for these 10 students, would you use the mean or the median? We would use the mean because it is symmetrical. Calculate the value of the measure you selected. So what is the mean? Everybody agree with that? 2.2 hours. All right, good. Moving right along. Page 15. Here is a dot plot of the data of the total value of coins. Total value of coins right here. Calculate the value of the mean and the median for the data set. Who's got the mean? $0.59. Good. What is the median? $0.31. Okay? Everybody knows how to find the mean. Everybody knows how to find the median. All right? Number 4, why are the values of the mean and the median that you calculated in problem 3 so different? Which of the mean and the median should you use to describe a typical value of the coins for these 10 students? The dot plot is skewed, therefore we would use the skewed the median. If it's symmetrical, let's look at the mean. If it's skewed, we're going to look at the median for a typical value. It's a better indication. C, 5 people were asked approximately how many hours of TV they watch per week. The responses are as followed. Find the mean number of hours of TV watched for the 5 people. 6 point what? 6.2? That's what I got, but I just added it up real quickly and divided. Everybody got that? If you add these all up, you get 31. Divide by 6. And so that should be 6 and, oh no, that'd be 6. That would be 5 and 1/6. That's not right. 31 divided by 6. I got 5.17. Did I miscalculate? 10? 10 and 15 is 25. Plus 6 is 31. Oh, there's only 5 numbers. Sorry. There's only 5 numbers. 5 numbers, so it is 6.2. Why did I use a calculator? Don't do that. Just use your brain. Okay? Now it says find the deviation from the mean for these 5 data values. The value from the mean, right? You're going to take 6 minus 6.2. 4 minus 6.2, 6 minus 6.2, 7 minus 6.2, and 8 minus 6.2. So that's 1.8, 0.8, negative 0.2, negative 2.2, and negative 0.2. Now, write a new set of 5 values that have roughly the same mean as the data value, but that has, generally speaking, greater deviations. Okay. So what you want to do is take 6.2 as one of your values. Okay, that's one of your values. I got 5. So now what I'm going to do to have the greatest deviation means I need to pick basically 4 numbers that are going to be the farthest away from 6.2 as we can get. We could do 100. But no, we just got to have the mean to be 6.2. So we could say 0, 0, 6.2, and let's do 10 and 10. Will that work? Now that's going to give us a median of, let's go with 12.4. All right. If you add those up, yeah, so I guess you would have to have it be 31 because you got to divide by 5. Is that 31 though? That's not 31. Yeah, it is. Yep, that's what we would have to do. Because those are going to give you a greater standard deviation away, or greater deviation away from 6.2. This one's going to have 6.2s, and this one's going to have 6.2. This is just going to be negative. How far away is 0 from the mean? It's negative 6.2. How far is 12.4? It's 6.2. Those are a lot farther away than negative 2.2, negative 0.2, 0.8, 1.8, negative 0.2. That's not that far away from the mean. But 6.2 is a lot farther away from the mean, but yet they still have the same mean. Got it? Good. 17. D says draw a dot plot for a data distribution representing the ages of 20 people, of which the median and the mean would approximately be the same. So when would the mean and the median be the same? Approximately the same. Yeah, as long as it's symmetrical. Okay. So let's do something like this. And do a dot plot. Beautiful. Dot plot. See there? As long as you know that the median and the mean will have about the same mean and median. All right, now draw a dot plot of a data distribution representing the ages of 20 people where the median is noticeably less than the mean. What kind of distribution is that going to be? Which way? It's going to be skewed right. You're going to have a skewed right distribution. Okay. Here will be closer to the median, but the mean will be over here. Yes, it's how you want to slide down the slide. You're going to go up this side and go whee, down the slide that way. Right? All right, was that all of 17? No, one more. An estimate of a balance point for a distribution of ages represented on a number line resulted in a greater sum of the distance to the right than the sum of the distance to the left. In which direction should you move your estimate of the balance point? So if you're trying to balance it and it falls off to the right, where would you move your balance point? To the right. Yeah. To whichever sum is greater, right? Wherever the sum's the most. So this says that resulted in a greater sum of distance to the right. So we would move the balance point to the right. Okay? Let's keep on moving. E. Look at the dot plot below. Ooh, look at it. Look, Linda. Estimate the mean of the dot plot. If I'm going to guess, if I'm going to estimate that, I'm going to estimate around what? Yeah, I would say between about 5 or 6. 5 or 5. About 5 or 5. About 5 or 6. B. Why do we say 5 or 6? All right, B says, remember that the standard deviation measures a typical deviation from the mean. The standard deviation of this data set is either 3.2, 6.2, or 9.2. Which of these values is correct? Well, 9.2 is definitely not correct, right? That's way too much. Is 6.2 correct? That means if we said it's in between 5 and 6, the next values would fall around 12 or around 0. Is that correct? No. Therefore, 3.2 would need to be what we said is our standard deviation. Okay? Now, this says 3 data sets are shown below. I'm sorry, that's not what it says. It says 3 data sets are shown in the dot plots below. Data set 1, 2, and 3, you see it there. Now, it says, which data set has the smallest deviation? What do we remember about deviation? When we're looking at a distribution, the greater the standard deviation, what? Huh? Farther away it is, what do you mean? Standard deviation describes what? Or is the value that describes what? What's another word for difference that we use? Variability, right? Or what does variability tell us? The spread, right? So if you have a greater standard deviation, you have a greater spread. It's spread out more. So which one of these would have the smallest standard deviation of the three? Set 1 would have the smallest because it's more compact. It's more closely clumped. B, which data set has the largest? Well, which one has the largest then? So this would be 1 and 2. Yes. Yes, yes, yes. Good job. Remember, standard deviation is talking about the variability or the spread. Okay? You'll learn in Algebra 2 how to get the standard deviation to be higher and how to get it to be lower. You can manipulate standard deviation. How do anybody have a guess at how you can make the standard deviation bigger or smaller? I take a guess. The more samples you take, the smaller the standard deviation is going to be. It's going to narrow it down. It's going to get more accurate, right? It's going to get closer to the mean. All right? Let's see here. Page 19. Use the statistical features of your calculator. What do you think this means? You need to have a calculator for your test come Friday. And preferably one that you could even put in there and it will give you standard deviation. Do you know how to get the standard deviation using that? There is a way to plug in these values and get the standard deviation. Yes. You need to Google or YouTube that. YouTube it. All right. Huh? So we could figure out the mean, right? How do we find the mean? Add them all up, divide by 5, right? And that would be, anybody do it? Did anybody do it? Yeah. Correct. The mean is 25.1 miles per gallon. Now, standard deviation, what would you guess the standard deviation to be? Just by looking at those. If the mean is 25.1, what would you say the standard deviation is? What'd you say? 2. It's pretty close. It's close. Yeah, look, your highest one or your lowest one's 23 and your highest one is 27. That would be 2 to the left, 2 to the right of the mean. The actual standard deviation is, though, 1.7 miles per gallon. That is 1.7. All right, guys. You need to have a calculator that you can do this. I've been saying it for how many weeks now? 18. 18 weeks. You need to have a calculator A graphing calculator. Coupon would be that they're expensive. You may want to check the teacher store down by Baskin Robbins. What was that called? Morning Glory? Maybe I'll find one there. All right. Number 2. White cap. You don't want to do it by hand. That's when you got to find the. You need to look it up on on YouTube. Say how to find standard deviation with that calculator, and it will tell you. All right. Number 2 says, suppose that a teacher plans to give 4 students a quiz. The minimum possible score on the quiz is 0, and the maximum possible score is 10. What is the smallest possible standard deviation of the students' scores? Why? Why would you say it's 0? Well, they could just all receive the same score. All could receive the same score. Is that how you spell receive? I before E except after C? No. Does that work for this one? I before E itself after C. It's not a rule, it's a suggestion. All right. Give an example of a possible set. Okay, yeah, so if all students scored a 6, 6, 6, 6, what's the standard deviation? 0, because the mean is 6, and then you don't vary away from it. So B, what is the set of 4 students' scores that can make the standard deviation as large as it could be? Use your calculator to find the largest possible standard deviation. But we don't have to do that, do we? What could they be? What? What are you saying 5 is? You're supposed to be giving me the 4 scores to make the largest standard deviation. 0, 0, 10, 10. That means the mean is 5, but your standard deviations are 5 away each time. So yes. But technically it's not. We would say that the standard deviation is 5, wouldn't we? That's what you would think. But it's not. Whenever you actually do the formula or plug it into your calculator, because you're dealing with square roots and squares, it ends up being 5.77 is the standard deviation. Did you get that? No. Okay. 20, page 20. G. A data set consists of the number of hours each of 40 students watch television. Man, we're all about this watching television. They have a minimum value of 3 hours. Okay, so all we're doing is creating a dot plot. Or not dot plot, box plot. Because we're talking about IQRs and stuff. All right, watch right here. How do we do? Refresher right here, box plot. Well, the minimum value is 3. Q1 is 5. The median, 6. Q3, 9. Maximum, 12. There you go. There's your beautiful box plot. It looks like a second grader made. Now, number 2 says, what is the interquartile range? How do you find IQR? No. Q3 minus Q1. Q3 is 9. Q1 is 5. IQR is 4. It's a range. What is the range between Q1 and Q3? 4. What percent of the students fall within this interval? How many fall between Q1 and Q3? How many fall between Q1 and Q3? 50%. Thank you. Come again. All right. Do you think that data distribution represented by the box plot is a skewed distribution? Why or why not? Do you think it's a skewed distribution? Yeah. Because your median is a little bit farther to the left. So it's going to be skewed right. Okay? 21. Using the histogram of the population distribution in the United States and Kenya in 2010, approximately what percent of the people in the United States were between 15 and 50 years old? Read it again. What was the question? Estimate the typical. Well, what are you going to say? 6. The median 6. We're going to say it's 6 hours. 21. Back to my question. Okay. This is approximately what percent of the people in the United States were between 15 and 50 years old? Approximately what percent of people in Kenya were between 15 and 50 years old? Well, if we look at 50 to 50, or 15 to 50, that would be from here to here. What would you guess? How much would you say is in between 15 and 50 years old in Kenya? You have to be careful because this is different. Your scales are different. Okay? We know that a third is between 0 and 10. So about 50%, you think? 60? So let's say about 60. What about for America? That'd be 7, 1, 2, 3. I'm going to say about 50%. Okay? And we just look at these values here. 15 to 50. And I said 1, 2, 3, 4, 5, 6, 7 times 7 is 49. So I said about 50%. All right. What 5-year interval of ages represented in 2010 histogram of the United States ages distribution has the most people? What 5-year? 45 to 50. All right, and that's all I have.